For stripping ratio, we can have volume of overburden over tonnage of ore, which is limestone. For each borehole, we can assume that the volume is length through the borehole over a diameter of 1 feet. So then we get thickness of overburden over tonnage of, so it would be feet instead of volume, over tonnage, and for tonnage we want density. For that calculation, you can go ahead, right click on stripping ratio and fill calculator. So first I have thickness of overburden, so this gave me feet. So I will, so if I assume it's length of the thickness, so it's thickness by 1 feet by 1 feet, so then it would be cubic feet, and all those ones will be added to that. So I assume a unit for that. So thickness by 1 by 1 over same thing for limestone. So let's have parentheses there and another parenthesis there. So I want tonnage. So I calculate, if I multiply it by 160, it will give me what unit did I give you here? So I have a 160 pound, so it will give me pound. So then I want to convert pound to ton. So whatever, so 1 pound is, what was the value? Is 0.0005 US ton. So we multiply that by that as well. So it give me right now feet on ton. So what if I want, so this is feet by ton. So if I want, so it's actually cubic feet by ton. So if I want cubic yard, that would be different. So then we need to calculate or convert feet to yard as well. But right now we use feet. And click OK. So I have this stripping ratio. The other thing is that these values, that thickness of limestone is 0. So it means that I have no tonnage of ore. However, here it calculates us as 0. If it was in Excel, it will give me undefined value. But in ArcGIS gave me 0. So let's define that a really big number, like 900. 900 there as well. And to make sure I've selected all the thickness of limestone that are 0, so you can go to select by attribute and define thickness of limestone equal to 0. Click apply and it will turn all of them as blue. So I can change this one as 900 as well. Okay, be careful when you are in your report or in legends. Alright, so we had a pause here. Now this is cubic feet over ton. So we know the unit for stripping ratio is cubic yard per ton, or in metric unit, but we are in US units. So I want to convert this to cubic yard. What I want to do is, first I want to save everything and stop editing. Now I create another field name stripping ratio cubic yard, and as a double. So next I start edit boreholes again, right click on that and fact calculation. So I just want to multiply thickness over burden, convert feet to yard, because we assume that all other dimensions of boreholes is 1. So I just, alright, then if I have a cubic feet to cubic yard, so I convert. So I just show it to you that how to make sure that you are on the same page. So I copy this value and so I delete everything. So I say cubic over and click OK. Now this is the stripping ratio that we have. So you can do this calculation in different ways. You can have calculate in one field tonnage of the limestone, cubic feet of overburden, then multiply, or then divide these together, or the way as I did. If you get different numbers, maybe I did it wrong, let me know, and then we can see who defined it correctly. So when you are completing this lab, make sure that you calculate these yourself and don't think that these numbers are correct. Alright, after having this, I can close attribute tab save edits, stop editing, save ArcGIS. Next, I want to create raster files. So make sure in customize item on top in drop down, go to extensions, and make sure you have 3D analyst and spatial analyst checked. Then close it, and then you can open where you had catalog. 2 icons on right of that you have Arc Toolbox. You have that open, and then you can mount it on right of table of contents here. Or if you don't see it here in Windows, in geoprocessing, you can have Arc Toolbox. To create rasters, you will go to a spatial analyst, third from bottom, extend it, go to interpolation. Now we have different interpolation methods. First that we have, so I explained 2 of them, then rest of that you can do it by yourself. I'm not explaining those in video. And then I'm going to explain total limestone tonnage calculation and average stripping ratio. Alright, so back here what we want is power of A is inverse distance, so inverse distance rating, so double click on that. Input feature in the drop down menu, select boreholes. The Z value that we want to interpolate it's for topography, so we have elevation. You can name the file as topo and power to 8. Is it? Make sure power of 8 and click OK. So it's going to think for a while. When you see this blue box, so it means that it's done. So it's added to your table of contents. You see it's like a picture. So if it's a raster file, it's like a picture with pixels. So next we want to create contours out of it in spatial analyst. Down here in surface, extend that, we have contour. Double click on that. We want to create topo raster file, the one that we just created. Now we want contour interval, so it started from 1140 to 1280. So if I have 10, I will have at least 14 contours, which is fine. So not here, sorry. So in contour intervals I put 10, and I can name it topo contours and click OK. It thinks for a while. It's down here, see it's thinking, and then the blue window shows that's done. You see the contours here. The contours is not matched with intervals of the raster file, so we can double click on the raster file name. Here in symbology, if you click, we can, if it's classified, you can click on classify, change it to define interval. If it fails, it's fine, and change it to 10. Click OK. Now you can select all these intervals with shift. So I hold shift and select everything, right click, format label, and you can reduce number of decimals to 2, so rounding to decimal places to 2. click OK and click OK. That's what we see. And also in value, because it's a classified, so we don't have any value here. That is fine. Now that it is matched, you can do the same thing for kriging. For overburden thickness, I'll shortly explain that. So back here in spatial analysis under arc toolbox, I'll go to interpolation, kriging. I will choose boreholes. The value is thickness overburden. I call it OBTHK for thickness. And unlike Carson, here we cannot see variogram, so it automatically matches the pattern and fit the curve unless we define these values, but we don't see and we don't know those values, so we rely on automatic fitting. And what we ask is spherical, so I choose spherical in semi-variogram model. It's ordinary. I'm not changing anything else, and I click OK. So a new raster file is defined. So if I uncheck the topo contours, so the new raster file is here. The issue is here in table of contents, what you see on top, so the order of the, so if I turn topo and overburden thickness both on, I don't see topo. So to change the order, if you go to list by drawing order, it is the order that you can see. So if you move something down, so if I turn it on, I don't see it anymore, but if I change it back there, then you can see. So I can have topo contours above topo and have both off. And now I want to create contours of overburden thickness out of the kriging raster. So I go back to surface, contour, double click on that. I will select overburden thickness and I name this overburden THK contour and the interval. So I see here 1924, and now it starts from 19 there to 65, so 20 to 65. If I have intervals of 4 or 5, it would be good. So I put intervals of 5 and I click OK. Thanks. And there it is. So it is a little bit mismatched with raster file, so double click on raster file and classify, define interval, change this interval size to 5, click OK. You can also hold shift and right click, format labels. I want to round it to 1 decimal number and click OK. That is the overburden. Do the same thing in same order. Oops, not this one. For top of rock elevation, limestone thickness, and stripping ratio with different interpolation methods. Next, I'm going to show you total limestone tonnage and average limestone stripping. Before that, another point is that the location of favorable stripping is that when you load the contours and raster file of the stripping ratio, where you have lowest contours, that is the favorable stripping ratio. Maybe it's around less than 2 or 3. That is based on what you decide, and you write that down. You can also draw a line around that as well. In here, if you have draw toolbox, and if you select a polygon, you can draw a line around that as well and show that boundary. Next, to have the total limestone tonnage and average stripping ratio. So we want total volume of limestone and overburden thickness layers. Okay, so under 3D analysis tools, at the first toolbox in Arc Toolbox, go down in functional surface. I first didn't find it, and then down in surface volume, double click on that. So first I want to define volume of overburden, so double click on that. So the output would be a text file with having the total volume. So overburden volume, and it would be above, everything is same. Click OK. Down here you have a text file. Next, do the same thing for limestone and LMS volume. Okay, now I have these two texts. So if I right click on it, you see and open the volume of that and the volume of that. So then you need a simple calculation. Convert this volume, this is cubic feet, convert it to cubic yard, then convert this to ton based by multiplying to density, then cubic yard of overburden over tonnage of limestone, and the unit should be cubic yard over ton, and that would be our average stripping ratio in total this area. Next, I want to show you how to have a plot. So for example, if I have overburden I want to have a plot out of contours of overburden and overburden raster file. So I have this and over the boreholes. If I double click on overburden thickness contours and go to label and check label features in this layer, and then I can have contours, so I can see the number of the contours as well. Also, if I again go back there in layer properties, so if you click on placement properties, I can have it on the line, and also I can change the color to green or dark green as well, so that's much more pretty. So down here you have a layout view. If you found it, click on that. Now that is the layout I want. I can see. Make sure to have this toolbox, which name is layout, on. So click on here and have this on. So I mount this up there. So here, if I select change layout, I can define the size of the plot. So I want a landscape. So in North America, ANSI, so I want a landscape letter. Double click on that. So then you can have that. So if I go back to my map by data view and zoom out and have it on center, go back to layout view, this map is changed. So if I double click on that, so now I'm in paper view, so that would be fine. Next is I want to extend this. Now I want to move the map to the right. So for doing that, I go back to the map. I move this a little bit to right. Go back to this and it is moved. So if I zoom here, that is going to be zoomed there as well. When I have this, next I go to insert and I insert a legend. So I select boreholes, OB thickness contour and OB thickness, and next. So you can define background, border and color and font size of that. After you played with that and define what you want, you can have that there. You can insert a north arrow as the way that you like and have that here and extend it. The most important thing, have a scale bar. So for a scale bar, for example, I define this and click OK. So I can have the scale bar like this as well, and you can double click on that and change the format of that as well too. Also, if you right click and go back to properties, you can have all of these values as well. So, and then you can extend the label. Back to the properties, if you adjust with width and for example define 500 and click apply, you can change the numbers to get the round numbers, and also you can make it bigger. For example, instead of number of divisions, you can have 6 and have more divisions here. You can play with the numbers, and after that, after you like it, you can go to file and export map, and you can export it as a JPEG file and save it wherever you want, and then have it in your report. So we want the same map like this for all 1 to 5, and then define favorable stripping ratio, these two calculations as well. Also, one more point is that if you want to draw an area, for example, as your favorable area, you can get here, draw a polyline or whatever around it, and double click. This is here, and if you double click on that, you can also have no fill color and for example have it, or you can change the thickness of line and outline color. You can change that as well, something like that, or you can delete it. Okay, so that's it, and good luck.